All right, I'm going to do the day three notes. Day three, or I'm sorry, unit three is pretty quick. Um, it just talks about graphing. Excuse me. Just does graphing as far as just these linear equations. We're going to use that a little bit more later on, of course. So it's a good thing to do. Get to do right. So I'll just give you some examples, and we'll head after it. All right. So this is an equation of a line. It's in slope-intercept form, right? Y equals mx plus b. So it lines up. So that tells me my slope is -2. My y-intercept is -5. So from there, all I got to do is say, okay, -5 is my starting point, basically. And then I've got to have a slope of -2. Well, I better hope that I find a slope that's kind of going this way, right? It's going down that way. So I know my slope is -2. Sometimes I put that over 1. So that means down 2 to the right 1. Well, I'm off the graph if I do that. So I'm going to go up 2 and to the left 1. Up 2 to the left 1. Up 2 to the left 1. I put as many dots on as I can. And there it is. That's our line. We got to finish it up. I like that Notability lets me make a straight line because otherwise it wouldn't be. And that's it. Make sure you put your arrows on, and we just graph that line. But again, the biggest thing for me, it's upsetting when I don't have a negative slope. I know I've got a negative slope because of this -2 right here. I know that I have to be going down as I go left to right. Keep that in mind. A lot of times people will have an answer that looks like that, and that's, of course, is wrong when we're going from slope-intercept form. All right, let's do this one. So again, it's worth the time to say, okay, my y-intercept is -5. My slope is -9/2. So I'm going to start at, green this time, -5. So again, down 9, nope. I'm going to go up 9 and to the left 2. Rise over run, rise over run. I'm going to connect those two lines. And that's it. There's our next line. So from slope-intercept form, it's really not that bad. Through number 3 in there, just to kind of as a reminder, if there's nothing in front of there, our intercept is 2, our slope is 1. So this one is very basic. +1 going this way. So all these points will help us out. And there we go. All right. And then on the last one, we know our slope is 2. We do not have a y-intercept on this one, so that's going to be at the origin, at 0. So up 2 over 1, up 2 over 1, up 2 over 1, down to the left 1, down to the left 1, down to the left 1. A positive slope, there's our line. Okay, I hope that's not new, and I hope that's something that you've seen before. Number 5, we talked in the last chapter about Hoy-Vux. This is a Hoy. Okay, it is a horizontal line. It has a 0 slope, and I knew it was a Hoy because it's a y equals kind of a line. So 0 slope, it's going to go at 3. So really, pretty easy to draw. I'm just going to draw a horizontal line at 3. So anything, every 3 is a 1, 3, 5, 3, 10, 3, -5, 3, everything. That's our y equals 3s. So now when I get over to x equals 5, this is a Vux. And I knew that because it's an x equals line. It's a vertical line going through 5. So right here, I don't even have to make points. Ooh, I missed a little. Let me move it over just so that'll bother me. All right, so there's that line, and so those are two kind of special situations, you would say. Okay. So now what happens if we get into standard form? All right, well, this is standard. This one is in standard form, right? Now we can do one of 2 things. This one's pretty basic. We could do this. We could say, okay, let's rewrite that, and that's going to be y equals -x plus 5, and I could just graph it that way. That's fine. But I also want you to have the ability to talk about the y-intercepts. Now, you might have to do that. because maybe it doesn't work out for the some of the slopes and stuff. But the other way to do this is to talk about the intercepts. So what I'm going to do is I'm going to write this equation out twice. And basically, I know that when y equals 0 in my point, I know that the x that'll be the x-intercept. So if I put 0 in for y, or basically just get rid of the y, that means x equals 5. Hey, 5, 0 is one of my points. Let's do the same thing down here, but I know when x equals 0, that's going to be my y-intercept, or basically x is gone. So y also equals 5 in this case. So guess what? There's my another point. Guess what? That's 2 points. That's all I need to graph. There's one, and that's my line. So if I have the 2 intercepts, I can graph. That's it. Now you could still redo it like this if you want to. Honestly, I don't care. It's not that, either way is fine, but I think it's worth looking at the standard form way. This one can work out as well. So if I wrote them twice, x minus 2y equals 4. So if I got rid of the y, that means x equals 4. So that would be 4, 0. If I got rid of the x, 0 something here. So this is gone. I get negative 2y equals 4 divided by negative 2. Y equals negative 2. A little different. Okay, so 4, 0 on the x, 0, negative 2. And there's my line again. I got to have 2 points. Okay? Say that like you can answer me. Anyway, now if I were to do this one, that doesn't look so good. If I were to try this one, I would say, okay, well, if I were to write this one again, I got 9x plus y equals 4. If I got rid of the x, that would be fine. But if I get rid of the y, I'd end up with an x-intercept of 4/9. Well, that's not going to work. I can't graph with that. So what I'm going to have to do for this one is, I'm going to have to go back to the other way. 9x minus 4. So negative 4 is my intercept. I'm going to go over 1 and up 9. So let's drag there all the way up to here. So that one I kind of had to solve. I don't want to be graphing fractional pieces. You can kind of estimate there. I guess a graph in and of itself is kind of an estimate, but that's just a little too much of an estimate to call good. Okay? So that's what happens when it just doesn't work. All right, one more. And this one we can do again. So we're going to go, I'm going to write it twice. Plus 4y equals negative 20. I don't want to scribble underneath there too much. So I get rid of the y. 5x equals negative 20. Looks like x equals negative 4. So that's going to be negative 4, 0. Get rid of the x. 4y equals negative 20. That looks like y equals negative 5. So 0, negative 5. So negative 4, 0, 0, negative 5. And that's our line. Connect the dots. All right. So we did one from slope intercept. All right, we did a bunch from slope intercept. Then we're going to do one from, we did a couple from standard. I'm sorry, I just got something just happened. So now we're going to do from point slope. Now, again, you have the same choice here, but sometimes it won't work at all. But you could, if you wanted to, you could put this into slope intercept form and graph it. But I want you to be able to pull the point out and just graph straight from this line. That's kind of the point of the exercise. So we can come up with the point. Well, what's the point that we go into? Now, the big thing about this, you got to remember to change the signs. This one is going to tell us our x. But remember, the slope of the form of the line is x minus x1. So the number we're putting over here is going to be not 1, but -1. Same thing going on over here. So it's not going to be -2, it's going to be +2. So that's fine. Oh, you're good? Okay. Have a good one. So then at -1, 2, that point is definitely on our graph, on our line. Here's my slope of 2, so I just go from there. Instead of going from a y-intercept, we're just going from there. So it all works the same. It's really the same concept, it's just a different starting point. Okay, now this one would have worked had you got it into slope-intercept form. But some of them won't. Some of them aren't, the graph won't be big enough for it to fit, and we'll see an example of that in a little bit. All right, so again, I'm going to pick the point that I want. It looks like 4, -1. Kind of the opposite of this, kind of the opposite of that. All right, there we go. 4, -1. Now I've got a slope of -2/3. So change in y is 2 over 1, 2, 3. Here we go. 1, 2, 1, 2, 3. Now look at this where we just kind of, this one we kind of needed to do this. Because if we'd have found put this in slope-intercept form, it would have had a fraction when we crossed the y-axis. And we would have been trying to pick that out. That wouldn't have worked. That wouldn't have worked. So we had to go do it kind of this way. That's one of the other reasons that we need to be able to graph straight from point slope form. All right. All right, let's head on to the next one. All right, here we're at, looks like 0.7, -5. So 7, -5 is right here. And the slope is -1. So we're going to go here. Oops, I'm sorry. Here, 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 here. So this one would have worked had we turned it around. Okay, but again, a little easier doing it that way. All right, and let's try this one. One more, sorry. Let's see, we got, let me grab a new color. I like grabbing different colors. How about 5 and -7? So 5, -7. Now this one, the slope is 8. So up 8, so 7, so all the way up 8 over 1. I guess that's it. That's all we can do because we'd be off the graph after that. So this one's going to look kind of like this. Why didn't that work? Try that again. There we go. All right, so there we go. That's that one, and that looks. I don't know. I kind of like that because that one's not touching the. That one's not touching the y-intercept at all in our little graph. It will at some point, but not on this one. All right. So that's graphing from all 3 forms. Now, the fourth thing we have to do for this test, I told you this was a kind of a short unit, is now we have to graph linear inequalities. So that's not an equal sign anymore. That's a greater than or equal to sign. We're going to do the same thing. We've got a slope of -5. We've got a y-intercept of also -5. So here we go. We're going to put a dot there. Then it's going to go, see, 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5 here. Now we've got 2 questions we have to ask ourselves. Number 1 is, are we going to draw a dashed line or are we going to draw a solid line? Well, the answer is right here. If it is an or equal sign, that means the line is included, means we are going to draw a solid line. So there we go. We're going to put that solid line up here. Now the second question is, where are we going to shade? All right, so here's what we have to do for that. I don't want you to think about the way sometimes teachers will say pick a point and decide if it works or not. I want you to think about it up or down. Okay. So if we're shading greater than, well, what does greater mean? Greater means more, higher, up, above, stuff like that. So I want you to put your finger on the line and go up. So if I'm here, here's where I'm shading. Here's where I'm shading. Up, above, greater than. So all the shade is all going to go right here. Okay? All right. Does that sound good? Just think about it up or down. I know this line is very steep and it looks like it's up and down, but it's not. But it's not. It's really got a slant to it. So it has an up, it has a down. Let's try that again. All right. So here we go. I got a greater than. So again, y-intercept of -5, slope of 8/3. So here's my -5. I'm going to go up 8 and over 3. So that gets me here. So that's all I can do. Now the question is this going to be a solid line or a dashed line? This one is going to be a dashed line because it doesn't have the or equal to. It's not included. So there we go. How about that? Notability came up with dashed lines now. So a little bit. Now, where are we gonna shade? Well, again, it's greater than, so I'm gonna shade above that line. I kind of went over the line a little bit, but that's okay. It's a little different that the actual graph isn't a way to get the answer. It is the answer. Okay? That's a little different thing with inequalities. So now I got two more. Now they're in standard form. Honestly, I just rearrange these. That's all I've really like to do. Let's just rearrange them and put it into, that way we don't make mistakes. So if I've got this guy, I'm going to say, okay, that's going to be -5y is less than -4x plus 15. I just moved the 4x over to this side. Divide by -5, so y not equals. Y is greater than. We had to switch the sign because it was we divided by a negative. We divided by -5. So that's going to be 4/5 x minus 3. So that means we start at the -3. Okay. Up 4 over 5. It is going to be a dashed line. So we'll do that. Why did that happen? There we go. Dash line. And it looks like we're shading above. I guess it doesn't matter what color. So there we go. Boom. Looks like a big puffy cloud. All right. So that's what I do is I always just solve for y. But again, watch your signs. Watch your signs for sure. All right. Let's go on to the next one. All right, so I got x. So this one I just bring the x over. So 4y is less than or equal to -x divided by 4. So y, we are not changing the signs because we divided by a positive number, we did it into a negative number. Looks like 0 is our y-intercept, -1/4. So we're going to end up with stuff like this. And this is a solid line because it is or equal to. So it looks like we are going to shade this one below. All right, and that's that. All right. Now there are two other kind of exception ones. And they are kind of the Hoy-Vux variety. So this is a y is less than 1. So we know that, first of all, it's going to be a dashed line. Let's grab some different colors. I know it's going to be a dashed line, and it's at y equals 1. Hoy, it's a y, so it's going to be a flat line at 1. So it's going to look like this. Greater than, and it's less than So we are going to shade below. So that one's really not that tough. That's really not, and by tough, I mean, that one really isn't any different than what we did before. Again, I didn't really say this before, but remember, the solutions to this set are anything that is below that line, anything that's shaded. So 3, 1, I'm sorry, 3, -5 is in there. 0, -2, that's in there. But because it's a dash line, like if I had 0, 1, that's not included because it's on the dash line, so you wouldn't include those at all. Now, what's a little trickier is if we switch over to a Vux type. All right. So this is going to be an x -4. Up, it's a dash line again. Okay. So here's a -4, so it's going to be a dash line. We'll put that in there. Boom, 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 boom. Now we're going to shade greater than this. Now this is where you have to change your thinking a little bit. X is greater, so that means, yeah, now I am thinking left and right because there is no up and down anymore. This is the one time when you would. So if it's greater, greater is to the right on inequalities. There we go. And that's it. And that's the last thing that we have. Okay, so go ahead and hit those worksheets. And honestly, this one should be hopefully one you can get a little ahead because I know in some of the upcoming chapters are going to take a little longer, especially the one when we get into factoring and some of the stuff with quadratics. So, okay.